Nico，很接江宁，可以一起玩了，我操！
来的，
就我们3个人。
我是3，
可以主持。Hector 为什么还没有来啊？
All right. Hello, guys. Welcome to Modern System Analysis and Design. And this is our first class. All right. So we'll be exploring chapter 1, system development environment. Okay. So in this course, we will be understanding the basic concepts of information system analysis and design. All right, what are the development life cycles? What are the different approaches, the traditional approaches and the modern approaches? All right, what is Agile methodologies, extreme programming? All right, how are they different from each other? So we will explore all of these components one by one. Okay. So information system analysis and design, right? They are complex organizational processes for system analysis and design. It is used to develop and maintain computer-based information system, all right? Used by a team of business and system professionals, okay? So in the 50s, the focus have actually been on automation, okay? When I say automation, I mean when you want to make things done automatically using machines or computers, right? Because then things were being done manually, okay? And in the 60s, those automations were now, there was a move, or the focus was on making them faster and more reliable, okay? Developing faster and more reliable computers. In the 70s, the system development became more like an engineering discipline. So it was engineers that we are actually exploring system development and design, all right? But in the 80s, there came a major breakthrough using case tools, object-oriented programming methods, all right? In the 90s, the focus was now on system integration, graphical user interface, GUI. When you hear GUI, remember, this is graphical user interface, applications, client server platforms, internet, all right? The new century these days came about web application development, wireless PDAs, component-based applications, okay? Also moving from computers, desktop computers to mobile application, everything these days, okay? Maybe 10 years ago, our mobile phone was supporting our computers. But now our computers are supporting our mobile phone. Everything is mobile. Everything is, you know, at your fingertip. So you see, technology is evolving. Technology is changing over time, okay? There is no application or technology that lives forever, okay? So it has to move with the times. So in recent times, the focus has been on speed and delivery. Speed and delivery of system analysis and design, all right? Planning of projects, project management, documentation has become very important. And the agility of system application analysis and design has also gained popularity, all right? So, and the cost of this program or this course, system analysis and design, you get to learn how to develop application softwares, all right? And all of you in this course are system analysts. What is a system analyst? An organizational role most responsible for analysis and design of information system, okay? So you all in this class are information system analysts and designers, okay? Because it is your job to analyze systems and develop them. So, system development methodologies. Now, in order to develop and analyze system, you cannot just develop system however you like, okay? You cannot just go into system development whenever you like, however you like, wherever you like, whatever you want, okay? There is a method or an approach or a way or a procedure or a technique you must follow, okay? And that is called methodologies. method, a style, a way, a technique, a step-by-step procedure you must follow. That is what is called system development methodology. Okay, it is a standard process followed in an organization to conduct all the steps necessary to analyze, design, and implement and maintain information system. All right, that is what system development methodology is. So if I ask you, what is system development? Please. Methodology is a step-by-step approach or standard process followed in an organization to conduct all the steps necessary to analyze, design, implement, and maintain information system. Remember this definition, I will ask you. Now, common methodologies, okay, includes the SDLC, evolutionary model, and traditional waterfall. Okay, these are the traditional methodologies: SDLC, system development lifecycle, evolutionary model, and traditional waterfall model. Okay, so we need to explore and understand the differences in these methodologies. Now, traditional methodology, SDLC, all right? System development lifecycle. When you hear SDLC, it means systems development life cycle, okay? So it is a traditional methodology used to develop, maintain, and traditional methodology used to develop, maintain, and replace information system. Now, this is a cycle, okay, of planning to analysis to design to implementation and then maintenance and then back to planning. It is a cycle. Maintenance and then cycle, you know, just like you have the word bicycle, because it has two cycles. I don't know how to draw, so don't laugh at me, okay? Bicycle. So this is cycle. So cycle means it goes in a circular motion, all right? That is the word cycle. So system development life cycle, okay? Every system have a life cycle, all right? We will explain more in detail. You can see, you start from the planning, go to the analysis, go to the design, implementation, maintenance, and then planning. For example, when this mobile phone came out, it was using the touch buttons, right? So before it came out, it was developed, it was analyzed, and then designed, implemented, and then maintained. And then after some time, touch screen mobile phone came out, right? And then you need to, again, plan, analyze, design, implement, maintain, and then upgrade. You need to plan, analyze, design, implement, maintain in circular motion, right? Most information system will go through this part, just like your computer, all right? Windows XP, Windows 95, Windows NT, Windows 2000, Windows 98, Windows Vista, Windows XP, Windows, you know, all of them. They all have their life cycle, all right, which starts with planning, analysis, design, implementation, and maintenance. Same thing with evolutionary. If you look at the word evolution, please check for the word evolution, all right? It goes also in a cyclical model, right? See? analysis, design, implementation, maintenance, then go back to planning, analysis, design, implementation, maintenance, continuously until finally the software reached the end of its life cycle, evolutionary model. Okay. And then what happens in each of these phases? Now we want to understand what happens in planning, what happens in analysis, what happens in design, what happens in maintenance, what happens in implementation and maintenance. We will explore one by one. Okay. The first part, planning. Okay. Before you can start anything, any project, you must plan. Prima, you must plan properly, right? An organization's total information system needs are identified. Why? We want it to do this, do that, do this, do this, do that, so that we can have a better system from the old system. This is planning. So you analyze, you prioritize, you arrange, and it's turned into a plan. This plan contains a feasibility study, okay, to assess the scope and purpose of the proposed development schedule. So the scope, what do you want to do? How big? All right, purpose, for what? What do you need? Why do you need a new information system? All right, and how long schedule? How long will it take to develop? Okay, will it take you 3 weeks, 1 month, 3 months, or 10 years? All right, so you must plan. So if it is too long, then you don't need such information system. If it is too short, if it is good, if the money is enough, you must plan. All right, so after planning, you go to analysis. So during analysis, the system requirements are identified. All right, the system requirements are identified during analysis. So what do I mean by system requirements? I have an old system, but it's not so good anymore, all right? Because we need some new functions, some new features. We need it to do so much more, but the system is already too old. We need a new system that can do everything, that can help our business process, our current business process, that can function better than the old system. So you need to analyze, you need to study the current information system. You need to study this system, all right? What is the problem? What can this system do? Who is the user? Why is it too old? What should the new system do? You need to examine, you need to system. What do you want to develop? What should the new system do? What can it do? What function should it do different from the old system? How can it benefit us? You study. So when you're done studying, you have a written description or recommendation that puts in detail, all right, the proposed system in detail. We want to develop a new system that does this, does this, does this, does this, because the old system is not good enough, because of this. So because during your study, you will find all this information. So the old system is not good, but the new system is going to be better because it can do this, do this, do this, do this. And then you give to your boss. Boss, this is the document for the proposal of a new system. So your boss can look at it. And then once your boss approves, say, oh, this is wonderful, give you some funding, some budget, and give you some team, then you can start your development. So the proposal comes out after your analysis. Sintong Lama? Do you understand? Sintong Lama? Do you understand what happens in analysis phase? in planning and analysis. Before you develop your system, you must plan and you must analyze the old and the new system. Study properly into a proposal. Tintong Lama, do you understand? Yes. So after your boss look at your proposal, you can check the meaning of proposal in Pinyin or Chinese or translate it so that you can understand what proposal is. Once your boss look at your proposal is a written document, okay, of what you want to do, of the new system. Then once your boss approve and give you funding, you can now go and start designing your application. So in design, there are two types of design: logical design and physical design. Now, design is actually, you know, all these architects, all these engineers, okay, before they build any building, any house, any company, any hierarchy, they design they would design the building completely on paper or on software. So you can see how the building is going to look when it is complete. That is an example of a design, all right? So a design is a description of the recommended solution, which is converted into logical or physical design. Now, logical design, all the functions or features of the system chosen for development, okay? Which means now we want to have a new system that can do this, do that, all the function. What is the function of the new system? What are the features of the new system? What can the new system do? So all the functions of the new system, okay, you need to describe it one by one, all right? Or documentation in the form of high-level requirements. For example, I want to develop WeChat. So what must WeChat have? I must be able to send message, okay? I must be able to receive message. I can make a call. I can make WeChat Pay. I can send videos, image, you see? So how can I send video? I must click this, click that. The file size must be less than 20 MB, shama. You see, detail requirements, one by one, you must describe, you know, in detail. Okay, this will help guide, okay, when they want to start developing the actual system, they need all this information. Do you understand? Now, the next part is the physical design. Please check for the meaning of this word in Baidu. Blueprint. Ask Baidu to tell you the meaning of blueprint. So blueprint, all right, the logical specification of the system from the logical design are transformed into technology-specific details from which all programmers and system constructions can be accomplished, all right? The designs will include parts of the system that deals with data capture. How do you capture data? How do you process data? How do you give the output? You must have this, you must have that, you must install this, capture, process, output. So you must give a blueprint from start to finish of the complete system, all right? And the final deliverable is a system specification to be given to the programmers for construction. After you're done designing the blueprint, okay? Then you give your blueprint to the programmers. The programmers will use the software like Java or Visual Studio or C++ or C#, whatever software they choose. They use that to develop the actual system, right? So during implementation, there are three main parts of implementation. The first is the coding. Coding is when you turn your design into an actual system. You code it, you develop the system, right? Once you finish coding, you must test the system. Is it working properly? Is it okay? Is there some mistake? Is there some error? Is there some problem? Okay, so if there are problems, you must fix all the problems. If there are no problems, then very good. So once you are done testing, you must do what is called installation. And you install the new system, okay? Once you throw away the old system, now we have a new system, we install the new system. This is installation, all right? So these are the three parts of implementation. First, you code. The coding is when you transform the design into an actual system, you code. The next is testing. After you're done testing, after you're done coding, you want to test if the system works perfectly, all right? Then you install, okay? These are the three parts of implementation. Tintong Lama, do you understand implementation? Do you understand the implementation? Okay, good. So once you finish your implementation, the next part is maintenance. So what happens in maintenance? Now you have installed the new system. Prima, you must provide maintenance. So maintenance and information system is systematically repaired. So maybe there are some damage or some error or some problem you must repair. This is maintenance. Or maybe there are some updates, version 1, version 2, version 3. You update. This is maintenance. Okay? So you must maintain this application or software for the entire lifespan of the software. For example, all right, but this phone is still being used till 2022. It means from 2010 to 2022, you must maintain the phone for all the user. You must give updates. If there's a repair, you must repair. If there is problem, you must fix. Maintenance. So maintenance continues until the system is no longer useful. See, you must continue maintaining until the system is no longer useful. Maybe because the business process have changed, or maybe because now there are new technologies, or right? For example, maybe 20 years ago, Messenger application was popular, right? Messenger, you remember Messenger? Chat Messenger, like Yahoo Messenger, Hotmail Messenger, QQ Messenger. There are many, many Messenger applications. But now these chat applications are no more popular. Now we have WeChat, we have WhatsApp, we have Facebook Messenger, we have Line, now we have different applications that replace the old application, because those old ones, they are no longer useful. Okay, we now have a new application. So once they are no longer useful, for replacement, you see, because Yahoo Messenger is no longer useful, we need to replace. So now we need to develop a new application, WeChat, to replace the old application, okay? So maintenance continues until the system is no longer useful, and then you prepare for replacement by maintenance. Do you understand maintenance? Do you understand maintenance? Now, this is what happens. Okay. Priorities of system projects are determined. Architecture for data network, you need to understand, study every part of the old system and the new system. So detailed step or work plan for projects. Specification of system scope, planning high-level system requirements, and then assignment of team members and other resources. System justification or you need new system, new application, new software, okay? All you need to identify in the planning. Then analysis. In the analysis, you describe the current system and where problems or opportunities are with a general recommendation of how to fix, enhance, or replace the current system with a new system. Now, of why we need the new system. This is analysis. So you analyze the old system and the new system, all right? Then you design functional detail function specification of all system requirements, data process, input, output, technical detail specification of all system elements, all right? So you design. After that, you implement coding, documentation, training, installation, all right? After that, maintenance. So the new versions or release of the softwares with associated updates to documentation, training, and support, you must maintain, all right? So I have explained to you the processes involved in this: planning, analysis, design, implementation, and maintenance. Do you understand? Sintong Lama? Do you understand what happens in planning, analysis, design, implementation, and maintenance? All right, and bam, bam. Okay, so the system development lifecycle, this is how you draw. If I ask you, draw system development lifecycle, SDLC, please draw this. If I ask you, draw evolutionary model, okay, please draw this, because it's, you see, evolution. You can check for the meaning of evolution. It's evolved. And planning, analysis, design, maintenance, planning, analysis, design, maintenance. It just goes on and on until the last part. So the final traditional method is called the waterfall. All right, you see the name, traditional waterfall, SDLC. Now, what is traditional waterfall, SDLC? You know waterfall, right? When the water falls from a mountain or stone or something, waterfall, huge, so much water, right? Water falls downwards. Water does not flow upward. The water will always come downwards, waterfall, right? Same with the traditional waterfall. You start with the planning, then analysis, then logical, then design, then implementation, then maintenance. Okay, you cannot go back. Now, this style of SDLC, it only moves in one direction: planning, analysis, logical design, physical design, implementation, maintenance. Okay, it does not go in cycle, or you cannot go back. This is traditional method. Okay, you finish planning, however, you go to analysis. Once you start analysis, you cannot go back to planning. Okay, planning finish, close. Analysis, you start. Once you finish analysis, you go to design. When you start design, you cannot go back to analysis again, okay? Because you're moving forward, you're not going backward, all right? All the way to implementation and maintenance. Once you finish, you cannot start again. This is waterfall. Tintong lama? Do you understand? So let us read what the slide says. The slide says, one phase begins when another completes with little backtracking. This means you cannot go back, okay? And you cannot loop. With little backtracking and looping, you cannot go back to any phase. All right, the system requirements are locked in after being determined. You cannot change. This means once I finish my planning and I start my analysis, I cannot change my planning again. For example, I say, oh, I need 1 million RMB to complete this software. When I start my design, I cannot change and say, oh, sorry, I need 2 million RMB to complete. No, you cannot change. Everything is fixed. Okay. So, for example, users, usually you ask them what they want in planning stage. Okay, what do you want? What do you need? I need new system. What do you want the new system to do? What function? Okay, I want to send message. I want to make call. I want to shama shama. I want a new WeChat application, green color, shama shama. Once you finish asking them this question, you start development. When you start your design, they cannot come and say, oh, Maribel, please, can you change some functions? Can you change some feature? I want to do this, I want to do that. No, impossible. You cannot change anymore, can't change. So limited user involvement only in requirement phase. So after requirement phase, once you complete, okay, we want this, however, that is what you will develop. You cannot change, all right? So that is what waterfall is all about. Tentang lama. Yes. So now we have described 3 traditional methods: waterfall, evolution, and SDLC. Okay, if I ask you to draw and explain, please, hopefully you can explain and you can draw. If I say draw SDLC and explain, you can draw this and give me some explanation. If I say draw evolution, you can draw this and give me some explanation. If I say draw waterfall SDLC, please draw this and give me some explanation, okay? I'm going to stop the class here so you can go for your break. And then when we come back from the break, we will continue with the rest of the class, all right? So see you guys after the break. Shesheni, bye-bye. All right, then, we'll continue with the class. As you can see, waterfall goes down only, no upwards. Doesn't go backwards. It doesn't flow upwards, all right? Remember that, that's very important. So there are other approaches aside the traditional ones, okay? Traditional modern ones that companies usually use now, because software analysts, they believe that system analysis and design or software development techniques or approach should be flexible, okay? It should be flexible. Please check for the meaning of flexible. It should be flexible because the traditional approaches are not really flexible. Okay, for example, waterfall is completely not flexible. You cannot go back. You cannot make changes to previous stages. For example, if Maribel wants to develop a software and she goes to Lillian, hello Lillian, ni hao, I want to develop a new system. Okay, so Lillian will say, Maribel, what do you want? And Maribel will say, I want this, I want A, I want B, I want C, I want D. And Lillian say, you want ABCD, Twima. Maribel say, I want ABCD. Then Lillian will start developing ABCD. So once she start designing, then Maribel come. Maribel say, oh, Lillian, Tipuche, I'm sorry, I want EFGH also in the system. But with waterfall, Lillian cannot go back. Twima, then Lillian will say, sorry, we cannot do this. We cannot add new system. We must finish this first before we can start a new contract. So you see, it is not flexible, right? So, but it is because of flexibility, time, delivery, and shama that you have different approaches to improving development. The first one is case tool. All right, what is case tool? Case tools are computer-aided software engineering. Okay, case, C-A-S-E, computer-aided software engineering tools. What does case tools do? They are diagramming tools, drawing tools to enable graphical representation, to help the representation of your methodologies or your design and your modeling graphically, okay, using computers, all right? So computer displays and report generators, okay, that help prototype how systems look. So with these drawing tools, you can see how a computer looks and feel, all right? Remember, case tools. Okay, analysis tools automatically check the consistency in diagrams, forms, and reports. All right, a central repository provides integrated storage for diagram, reports, and project management. All right, and then you have your documentation generators. All right, they are standardized technical and user documentations. Okay, code generators enable automatic generation of programs and database code directly from design documents, forms, and reports. Okay, these are all computer-aided software engineering tools, case tools. Example, you see, this is rational rules. Okay, used to draw class diagram. We will do some of these in the. Okay, so now you just need to understand the basic concept. Okay, see, this is rational rules software. Okay, this is a case tool used to draw class diagram. See? So the next one is RAD, rapid application development. The word rapid, it means very, very fast. Okay, so it is a methodology that reduces or decreases design and implementation time, because you want your design and your implementation to be very, very, very fast. Okay, you don't want to use traditional method. You want to use rapid application development. You see, this is why I said these are modern technology method, all right, in order to reduce time, increase efficiency, you know, increase flexibility, unlike the traditional method, all right? It involves extensive user involvement, okay? For example, Maribel now goes to Lillian. Lillian, please, I need you to develop a system for me. I want you to develop A, B, C, D. Lillian said, are you sure? Maribel says, 3. I want A, B, C, D. So Lillian goes and develop A and B and shows Maribel. Maribel, so far I have developed A and B. What do you think? Is it okay? Wow. How about, okay. Can you add D and C? Yes, I'm going to add D and C, but I want you to see how A and B looks first. Then, okay, develop B, C, D. Then Lillian developed the next part, show Lillian. Then Lillian said, oh, I remember something new. I want you to add EFG. Okay, how about no problem? Everything is still okay. It is flexible. Then Lillian can add new features. You see, they will have something called JAD sessions, which means everybody involved, joint application design sessions, everybody involved, all the stakeholders or shareholders, your boss, your designer, your programmer, your system analyst, your coder, your tester, everybody involved, they can meet, have a meeting, discuss, have a discussion. What do they want to develop? What stage of this system are we designing? They can add some new features. They can discuss step by step, stage by stage, from start to finish. This way, everybody can have a perfect system, right? If they want to make some changes, they can, please hold on, give me a second. I need to take this call. All right, sorry about that. So they will also integrate, they will also use computer-aided software engineering tools to show the drawings, to show the development stages, to show the designs. You know, they have their meeting, they have their discussions. This is going to help in reducing design time, reducing testing, reducing implementation time, reduce and increase efficiency. This is why it is called rapid application design, okay, development. All right, so you can see, this is the rapid application development lifecycle. Requirement planning, then user design. After user design, construction. Once they finish construction, they meet with the users or meet with the stakeholders. They discuss, is everything okay? No, I need to add this, add that, add this, add that. Then they go back to construction. This will go on until everything is perfect. Then they go on to cut over. Tintong Lama, can you see the difference between rapid application development and other traditional method? Tintong Lama, do you understand? All right, so we'll go to the next part. Agile methodologies. Now, Agile methodology is also similar to rapid application development. Basically, it also has the same intention or the same goal, okay? Agility in methodologies. You can check for the meaning of Agile in Baidu, okay? You know, all the sports people that play sports, football, basketball, they must be agile, they must be flexible, they must be quick, they must be fast. Their dribbling is very good, their movement, their, you know, their strength, agility, all right, flexibility. And those players that have a good agility, they are usually very, very one of the best players, okay, for any sport. And that software development is as fluid or unpredictable and dynamic, okay? Which means, you know, fluid like water. Water is dynamic. Water is not fluid. It's not fixed. Ice cannot change form or shama unless it is water. Water, you can put water in a cup, you can put water in a plate, you can put water in a spoon, a pail or the bucket. It is flexible, but you cannot put this phone inside a cup and it will be perfect. Or you cannot put this phone inside a bottle or inside, you know, it is not flexible. So software analysts, they say that that software development should be flexible. It should be, because sometimes people want to develop something of what they want to develop, but they don't know all the parts. But during development, maybe they will find out all the parts, right? For example, Maribel wants to develop something, but right now she only knows A, B, C, D, but she don't know the remaining parts. But only when she starts, when Lillian starts her development, oh, wow, this is wonderful. Okay, now she knows the full picture. She knows the C, D, E, F, G, H, I, up to Z, maybe, you know, because it needs to be flexible. It needs to be unpredictable. It needs to be dynamic. Prima. So this is what Agile method is focusing on. All right, adapt. It needs to adapt and not to be predictive, which means it needs to accept changes. You cannot say, oh, like the traditional waterfall. You cannot say, oh, sorry, we cannot make change. We have to stick to the first agreement. You said I develop ABCD, finish. I cannot change. All right. So you must be able to accept changes. All right. And its focus is on people. You work with people, teamwork, team discussion. All right. Not planning, finish, analysis, start, design, finish. No, it has to be flexible. This is what Agile method is talking about. All right. So you can read this part and get more information. For example, look at this explanation here, okay? You can see in the beginning, Maribel comes and meets Lillian. Application that can be tied to a tree, okay? That people can sit down on the tree and, you know, and play. This is how Maribel explained to Lillian. So Lillian was listening to Maribel, and Lillian, this is what Lillian understood. So you want the something that looks like a seat, a chair that is tied to a tree. Tuima, Maribel said tui. But Lillian, this is what Lillian understands, and this is what she designed on the paper. Then she gave the engineer, my client wants you to develop a swinging whatever that sits on a tree, okay, that is tied to a tree. Then engineer was thinking, but if I design this, it cannot swing. So engineer decide to cut this part of the tree and put some engineering fulcrum here so the tree can stand and then it can swing. This tree will be dead. It's not functional. It's not feasible. Then technician decide to design the swing like this because this is the best way for this tree to stay alive. But actually, this is what Maribel wants. But because she does not know exactly what she wants in the beginning, but actually this is what she wants. Can you see? Yeah, Lillian has a different idea. Lillian boss or Lillian teammate have different ideas. So because everybody have different ideas or different design things, okay, they will end up doing different things. But if you work together, okay, you see, users don't always know exactly what they want from the beginning, all right? But if you work together step by step, before the end of the development lifecycle, everybody can share ideas, everybody can share design opinions, suggestions, progress, and finally they will come up with the best solution, happy for everybody. Do you understand? So this is what the emphasis of joint application, Agile methodologies are focused upon. Okay, so if your project involves, so you need to know when to use what methodology, okay? You need to know when to choose Agile methodology or traditional waterfall or evolutionary model or SDLC, okay, or RAD. You need to know, because every project, every team, they have different methodologies that is best for them, all right? For example, if your requirements are unpredictable and dynamic, for example, Maribel come to Lillian company. Maribel don't know exactly what she wants. Completely, 100%, she doesn't know. She just knows some part. Please use Agile. But if Maribel know exactly what she wants, perfectly what she wants, okay, from A to Z, and she wants you to do it exactly how she wants, please use traditional method, because traditional methods, they are easy to use from start to finish. Everything follows step by step, documented, and the process is very clear. All right. Now, if you are responsible and you have a lot of experience, you are an expert, you have been working for software development for many, many years. So you have seen and completed the development of many softwares. And you know that sometimes these kind of users, they will come back and make some changes later, okay? Because the requirements they give you right now does not look, you know, based on your expertise, you can use Agile method. Analyst or system developer or a project manager, and you don't want to make mistakes or shama, please use traditional method, because traditional method, they give you security, safety, because everything is step by step. Everything is documented. This is what you want, and this is what I developed based on what you want, okay? Now, for customers who understand the process and are willing to get involved. Now, customers that, you know, some customers, they want to know what you are doing step by step. They want to know after every changes, they want to see the progress, use Agile. But some customers, they just, or some clients, they just want to, one time, they visit you one time, they tell you what they want, finish. Just what I want is the product. Give me the answer, give me the solution. I don't want to discuss. Have you finished? No, then why are you calling me? Don't call me until you finish my software. You see, that type of customers use the traditional method, okay? But customers that want to get involved, customers that want to ask questions, that want to give some new information, customers that want to add change, that use Agile method. Do you understand? Sintong lama? Yes, so every method is different, okay? So what are the 5 critical factors that distinguish between Agile and traditional approaches? Now, size. The first part is size. Well matched for Agile method, it is best for small products and small team, okay? Reliance on tacit knowledge and maybe small team. But if you're working with a big team, whereby everybody have to play their part, everybody have to do their job, you cannot really use Agile, okay? Because everything is going to be messy. Now, traditional method evolves to handle large products and large team, okay? so hard to tailor down for small projects. If it is for small projects, better use Agile. But if it's for big projects, expensive project, please use the traditional method, because you want everything to be done step by step, properly, clearly, 100% clarity, with no mistake. Because if big project, if there is a mistake, it's going to cost billions of RMB, millions of RMB to fix, but you don't want that. So you want everything step by step and clear, right? Now, if the project is critical, okay, untested on safety critical product, potentially difficulties with simple design and lack documentation, then use Agile. But this method evolved to handle highly critical product, all right? If it is very expensive or very big project, please use the traditional method. But if it is flexible projects, small projects, use Agile method, all right? You look at the dynamism. Dynamism means flexibility. So simple design and continuous refactoring are excellent for highly dynamic environments, but a source of potentially expensive rework for highly unstable environments. You see, continuous refactoring, the user always come and make some changes in their requirement, what they want. Today, I want ABC. Tomorrow, I want EFG. Next tomorrow, I want HIJ. Next day, I want something. You see, changes. Please use Agile, because when there are so much changes, you cannot use traditional method with so many changes. So detailed plans and big designs upfront, excellent for highly stable environment. All right, you use traditional method. But the bad thing is, if you have some new changes, it is very expensive, because you must finish and start again, right? For traditional method. Now, personnel, if you are using Agile method, okay, requires continuous presence of critically mass scarce experts. Now, for Agile method, it is usually for skilled people, experts, people that have experience, okay, in software development. New software design developers, they cannot use Agile method. See, risky to use for no Agile people, people who are not experienced, people who are not Agile. Please don't use, if your team is new, they need to follow the process, all right? But Agile people, they already know the process. They already know everything. So newbies or noobs or new software developers, basically, it is best to use traditional method, all right? See, need a critical mass of scarce experts during project definition, but can work with fewer later in the project, which means if there are no experts in the project, it's okay. You just need experts in the beginning to approve the project and to look at the requirements and shama. After that, because everything is step by step, they can just follow the steps for traditional method, all right? So culture, this thrives in a culture where people feel comfortable and empowered by having many degrees of freedom. You know, for example, if your boss is the kind of boss that allow you to be creative, your boss allows you room to be flexible, okay? Agile method is good. But if your boss is a very strict, follow my instruction, you cannot change, you cannot use your idea, then you must follow. This thrives in a culture where people feel comfortable and empowered by having their roles defined by clear practices approved. And by clear practices, which means you must follow the boss instructions. You must follow the procedures by the company or by the organization. You must follow the procedure. You cannot have your own idea. You cannot have your own style. You must follow the company style or your boss style. All right? Tintong Lama, do you understand the difference? Do you understand? Between Agile and traditional method. All right, very good. The next part is extreme programming, okay? So you can see that all of these new styles of software development, basically their focus or their objective or their goal or their intention or what they want to do is the same, okay? They just want to make things faster, make things flexible, make things quicker, make things much more efficient than the traditional method, okay? It is a short incremental development lifecycle. Automated test, two-person programming team. This is best for a two-person programming team, extreme programming. You code, you test, you code, test, code, test, code, test. You code and test, they operate together, all right? Communication between developers are the most important part, okay? The teamwork is so strong, okay? High level of productivity and high quality of code, all right? Extreme programming, two-man programming team. And then finally, object-oriented analysis, oriented programming, right? And this is also another methodology, object-oriented analysis and design. Now, these are based on object rather than objects, a structure encapsulating attribute behavior of a real world entity, like classes, all right? You have classes. We are going to study all this one by one, so don't worry. Important thing is for you to get the concept, okay? Understand the basic concept. So when you talk about object-oriented programming, you talk about objects, you talk about object class, and then inheritance. So let me explain. For example, student is an object, right? Student is an object. Teacher is an object, right? A structure encapsulating attribute and behavior. So what are the attributes of a teacher, of a student? The student will have a name, student will have age, student will have address, student will have what year? Okay, 20101, prima. Then, you know, what province are you from? Oh, he's from Beijing. You see, these are all attributes of the student. Now, what about the behavior? You must take class. You must, student must do homework. Student must write exam. You know, student must write exam. Student must pass exam. See, these are all behavior. Prima. Same with teacher. Attributes, you see, name, attribute, behavior. These are object-oriented analysis and design. So teacher will have a name, same, address, country, age, expertise. What course can you teach? Oh, this teacher can teach programming. This teacher can teach system analysis and design. This teacher can, you see, what class they can take, shama, shama, shama. So teacher must go to class. Teacher must teach students. Teacher must write exam. Teacher must, you know, these are behavior. Prima. So see, object class, a logical grouping of objects sharing the same attributes and behavior. So you see, this teacher, this particular class is applicable for all the teachers in Hunan University of Art and Science, correct? Dr. Hector must have all this information. Dr. Patrick must have all this information. Dr. Tom, every teacher must have this information. Same, all the students in this class must have all this information. See, Bridget, Nicole, Lillian, Maribel, Kevin, all of you must have your name, student ID, address, class. You must take home, do homework, write exam. See, object class, a logical grouping of objects sharing the same attributes and behavior. See, all of you in this class, this is why it is called class, will have the same, will share the same attributes and behavior. Okay, then inheritance, and okay, all of these we will explore in further chapters. But the most important thing is for you to understand the basic concept. Okay, so now how does these two relate? Usually, a teacher must teach. A teacher must teach students. See, teacher will teach students. So all the classes will have relationship between each themselves. Okay, right now just understand the basic concept. Okay, so let me see, are we done? Yes, and this is the end of chapter 1. So chapter summary: define information system analysis and design, describe information development lifecycle, describe evolutionary method, okay, describe waterfall method, okay, explain rapid application development, what is case tools, case, prototyping, okay, describe agile methodologies and extreme programming, okay, and explain object-oriented analysis and design. All right, so if you can answer these questions, then any of the questions that come out in mid-semester exam or final exam, you can be able to answer. All right, so now I want us to have discussion, okay? Can you tell me what you understand by SDLC or evolutionary or waterfall in your own understanding? Okay, you can unmute yourself and type, or just type from your own understanding. What do you understand by traditional system development lifecycle or evolutionary method, model, or waterfall model? Okay, just explain to me. Tinton Lama, do you understand what I'm asking? Do you understand my question? Do you understand my question? Okay. My question is, from your understanding, can you tell me what you understand by SDLC, or the difference between SDLC, evolutionary, or waterfall? You can choose. Explain any one you can. Just give me explanation, simple explanation of your understanding of SDLC or evolutionary model or waterfall. Do you understand the question now? Maribel, do you understand my question? Here, this is SDLC, System Development Lifecycle. This is evolutionary model. And this is waterfall. So choose one and explain to me what you understand, your understanding. Sitong Lama? So give me, what do you think? Tell me. You can type. This is the end of the class actually. So now it's just discussion, all right? So we are reviewing the concepts that we have explored in the course of this slide, all right? So concept, understanding. So tell me what you think from each of the concepts we have explored.